Jane, as we go through, I know that we've lined up a number of organizations to talk about their the data that they're sharing. If you can figure out which order to go with those, that'd be great. What I thought I'd do is just start with a quick introduction, which provides some reference about the kind of data that we share in our domain. So largely this is for the benefit of the CGI team. We have in WMO recently approved a new data sharing policy, which covers all the Earth system domains. If I just find the right page, you will see what I'm talking about. Bear with me for a moment. We'll share my screen. Do that one. Okay, so you can see that we have the WMO Unified Data Policy, which is Resolution 1. The text of the resolution can be found on this website. I'll share it all. And importantly, there's a catalog of core data that you can look through here. Now, this is a little out of date. Jane, your hand is still raised. Did you want to come in? No? Okay, perfect. So if I just give a quick overview of what's in the regulation, the main thing that we're interested in is the first annex to this resolution, and I will make that bigger. What we find in the WMO data policy is that we're splitting things up into each of the Earth system domains. They cover weather, climate, hydrology, atmospheric composition, so that's chemistry in the air, cryosphere, oceans, and space weather. For rodeo, I think that we're pretty much talking about the weather and climate domains. Within WMO, we categorize things as core data, and that's stuff which needs to be that's a requirement for all countries to share, and that will be free and open access. So broadly speaking, that's overlapping with the HVD data types, and then we have recommended data, which is other useful data that our WMO members and WMO programs share that might come with some access requirements, such as usage for non-commercial activities, usage for research activities only, that kind of thing. If I were to look at the catalog of core data, you can start to get a feel for the kind of things that we share. So we have surface-based observations, which are really time series data, or spot observations at a particular point in time of things like atmospheric pressure, air temperature, humidity, wind speed, precipitation, snow depth, those kind of things. We have upper air temperatures. Those are categorized. We can see those as we have things like radiosondes, which are, if you imagine, are an observing system attached to the bottom of a balloon, and as it goes through the atmosphere, it records a number of parameters, and that gets packaged up into a data file. We have satellite data, which you're probably familiar with satellite imagery. Our data uses soundings through the atmosphere as well, so that we can actually build a three-dimensional cube of data, and that is shared. We have surface-based meteorological observations from a whole bunch of different places. And then we move into the data that comes out from numerical simulations. So here we tend to use computer models to understand the state of the atmosphere, and we can build 3 and 4 dimensional views of the data, and they tend to result in quite large data sets. And I think that as we see what's being shared by each of the people here, you'll get a feeling for what our model data looks like. I'm going to stop there. You can work through these things in your own time and come back. But you can see that WMO tries to describe the kind of data that is shared, and I think that's in a little more detail than is specified in the FEMDI requirements around data for climate prediction, radar, and surface observations. Estelle.
Yes, thanks for this. I just wanted to add that there's also, this is like what we globally want to exchange, but there's also for the different region, I think that's also important for us to know that there's additional information as well, such as radar data, which is not being part of the WMO data policy at the moment. So there will additional measurements be also relevant for example, for Europe and what we need to exchange in FEMDI. So this is not the full picture. There will be more, so it's kind of an addition. What will come there? Just as information.
Yeah, that's a really useful addition. Essentially, this just gives you a flavor and a reference that you can look at to have an understanding of some of the data that we're sharing. But we want to make it real, so that's why I wanted some of our team to share with you the kind of data that they're publishing routinely, and in some cases the APIs that we're using to make that data available. So Jane, I don't know if you had hi Aruba. I don't know if you had you do have a suggested order. Okay, so NMHS examples. We have Mikko Visa up first with FMI.
Yes, just a minute.
I'm just going to paste into the chat some links to what I was talking about.
So where's my screen? You can see it now, I guess. Oh, no.
Yeah.
Not this one yet. Just a minute. It was the PowerPoint that was I supposed to share first.
Jeremy, I just have one question. I realized I'm sitting in the web browser. I don't know if I'm able to share through the web browser through Teams. I don't find any button for that.
Okay. Do you have the Teams client?
We prefer not to install those clients,
okay.
actually. But I could do that. Then I have to come back. Okay, should I send you the slide? It's just PowerPoint with a.
Yeah, have that one going as a plan B, and I'll quickly have a look and see if there's a way to share screen through the browser.
Okay, sorry for that.
No problem.
Yes, so I was asked to keep this presentation yesterday by Mikko Rauhala. So apologies if I'm missing something from the slides, but I think it should be quite clear, and I'm trying to just shortly demo what the EDR looks like. But first, some general slides about the FMI open data, it seems. So in 2013, everything was mostly opened, including both real-time and historical, and also climate data. And so free license in a machine readable format and so on, based on the Inspire stuff that was going on at that point. In 2020 there was actually, these are old numbers, about 740 million requests per year. So that's about 1400 requests per minute, but that's not, I think it's almost double nowadays. But regarding APIs and channels, so currently we have WFS 2.0, which is kind of the main download service. We have API features also with some climate data, if I remember correctly. That's on beta status. And OGC EDR as well. It's just been developed, and it has already the most of our datasets available. Then there's WMS and kind of a binary download WCS-like service that's non-standard. And then we also have some datasets in Amazon S3, some radar images, air quality model, and something else was there also. Most of these are served from our SmartMat server, which is open source, and it's can be found on GitHub. Then we have the total requests that are actually, so that's 741, but I think it's something like 1.3 billion or something in 2022, I guess. I think something like 40 requests per second is what's running right now. But let's move on to EDR. I think that's the most important part in this presentation. So we have installed EDR right now in operative environments. It's not been advertised yet anywhere, but it should be quite operational. Currently we have grid observation, and then we also have the aviation OPMET data available through EDR. And as you may know, EDR supports different kind of queries. That what we have currently is the area, the corridor and trajectory, and then locations, position and radius type of queries. And I guess model, I think this means that your model runs you can get as instances to EDR, if I'm not mistaken. And the output that we are currently having is coverage JSON. I think at some point there might be some other formats also, but I think this is the most important one. The endpoint is here. I'll show you that one just in a minute. We don't have any kind of HTML output, so you cannot kind of browse the collections yet. That's still on the to-do list. And also that means that the search engines cannot really index the site yet. Then let's move on to I'll show you the actual implementation. One moment. Just have a small laptop screen, so it's a bit difficult to switch between windows. Now. I think now you should see the browser, if I'm right. So here is what it looks like if you put the endpoint in your browser. It's just listing the actual collections in JSON format. So it's not really nice to browse it like this. But now we can take the URL of the endpoint and we are going to be using this nice graphical user interface provided by MetOffice. So thank you for that. It's been very useful in our development work. So it works like this, that you put your own EDR endpoint in the box here and just click retrieve collections. And after that, you have a drop-down lists with all the collections that are available in your server. So I'll try something like, let's take the easy model here. Here you can select which model run. We'll keep it, I think that's the most recent one. Oh no, it's actually not, that's the most recent one. And let's, for example, try a position query, and we can select this button here, and then we can just click on the map and get some coordinates here. After that, you can choose the parameter name, for example, humidity. Click next, then it gives you the available times that are in that model run. We'll just take the first one as start time, and a couple ones to, let's take this one for end time. Is it, yeah, 03 to 12? Click next, choose the output. It's only this one from now, and then you can choose output format. How it actually lists JSON also. I didn't know that we have that already, but let's stick to coverage JSON. We are only looking at the actually here from the GUI. So then I get humidity here, click it, and then you get the values for that point. So that's just one basic demo on how to use the EDR. And just mentioning that if you want to see the actual data, then you get the URL down here. You can copy paste it to another tab, and then you get to see what it looks like in JSON format. All right, so that's very quick and short demo. I'll go back to the PowerPoint now. Oh, there's only one slide left, so not much. Then we had also a mention about the API key. So when we started Open Data, we had registration. We had also this kind of API key, but later it was removed, and it was actually a good decision because there was it's kind of more open data policy without the need to register, and it's also hard to maintain, and there's all kind of GDPR issues. So we are very happy that we took the API key away completely. There has been no problems as far from this decision. Yes, so that's basically all that the other Mikko wanted to tell you, but if there's some questions or something, so
Okay,
thank
so
you.
thank you very much, Mikko. Do we have any questions for clarification? Anything from our CGI friends? Okay, so hearing none, let's move on. Anders, did you manage to find the share screen button on a different version of a browser?
I've actually installed the Teams client, so it was quick.
Okay.
But I'm still trying to find the.
So normally the share screen is like an up arrow right next to the big red "Leave the meeting" button in the top right corner. If you want to have I can skip to Peter and give you a bit more time to familiarize yourself with the Teams client, if that would be helpful.
Oh, thank you.
Is that okay, Peter?
Sure, that's okay.
Okay, I'll come back to you next, Anders. Peter, if you want to take over the helm.
Yes, sounds good. All right. I assume everyone can hear me. All right. So yeah, thought we were going to talk about the metadata. That's at least what I've pulled up. I'm just going to do more of like a demo. We have our documentation here on like a Confluence page. You can find this if you Google DMI Open Data. And here you can look at the meteorological observation API, everything you need to know about the API itself and the parameters we have.
Hi, Peter. I don't see your screen shared.
Oh yeah, sorry. That is of course something we need to do. Let's see. Entire screen. Yes. Right. How about now?
Perfect. Thank you.
All right. Here's our conference page. And as we've built our solution on the features API, which was the only approved standard of the, I guess, second wave of the OTC standards back when DMI started publishing data. Works well enough for meteorological observations at least. But yeah, that standard builds an open API, so you get the Swagger client for free. So that's what we're looking at right now. And here you can see what endpoints you can call and stuff. There's like only one collection for our MedOps API. We chose to make a separate API for each type of data. So yeah, this is a pretty simple one with only one collection, the observations collection. And we can, of course, try it out to look at what we get back. I'm just gonna put in here. So the Swagger client, when it's not gonna pass, not gonna pass a lot of JSON. So yeah, we can just execute that query. We can get the full URL of the query, and we can see what we get back. And that's of course good old GeoJSON. I think the most interesting here is what type of properties we have. Basically have an observation time, always in UTC. We have a parameter ID, station ID, and then a value. The station ID you can use to look up stations. This is a separate collection. Oh yeah, so there are two, observations and stations. And get all the metadata we have on those stations, like barometer height and so on and so forth. We also have in our documentation under our data information descriptions of these parameter IDs. The units, descriptions, how often you can expect them to come, and whether or not they're available for Denmark and Greenland. Yes, so that is our solution here. Yeah, I think that's it, unless there are like questions from the CGI team or something like that.
So, Peter, if you go back to your the Confluence page that you started on, you've got 6 different types of data.
Yeah.
So, can you just briefly describe the characteristics of each type of those data to give our CGI friends a bit of an understanding about what we mean when we say lightning data? What does that look like?
Yeah, sure. Let's see, lightning data. Lightning data is, let's put a limit on. It looks like this. So yeah, we basically have where the lightning strikes and its amplitude, how many strokes are there. We also
so basically,
have
This is like a point cloud of where lightning occurs with some intensity, and you have a geospatial location and a time.
Yes, exactly.
Yeah.
We also have the raw sensor data itself, and of course the stations. There are a few lightning rods which you use to triangulate the lightning itself. So our observations is actually the calculated value, the triangulation.
Mm-hmm.
If you want to perform that triangulation yourself, there's also the raw sensor data available in our solution.
And then quickly, if we went back to the other 5 categories of data, can we just have a like 30-second run through of each of those?
Sure thing. For our climate data, we have a bunch of different stuff. Let's see, is there a good explanation of it here? Yeah, here we go. So we have a few different spatial resolutions, we call them. We have station values and a 10-kilometer grid, a 20-kilometer grid. Then for the municipalities in Denmark, there's around 100, and then the whole country. As you know,
so I was just going to say, just to add, for our CGI friends, when we talk about stations here, we're talking about observing stations or weather stations. So those are physically where we have put observing equipment, and often our climate stations are long-running collections of data gathered from information or gathered from observing capability at the same point. When we talk about grid values, what we're talking about here is like a simulation or a model, and you have the values from that grid, the value from that model on a 10-kilometer grid resolution or a 20. Yeah, exactly like that. Morten.
Yes, I would just add that the term station value it was discussed, but basically it's actually the same as an observation in the meteorological observation that Peter started showing out. It's just with quality control values. So we discussed what to call it, and we ended up with station value because it's a value measured at a weather station. So it should be, unless there are errors, it should be identical to the actual observation that is also available in the MEDOF's APIs. Yeah.
Okay, cool. Thank you.
Yeah, we have a long, we have documented a lot of stuff. We have a lot of text, maybe too much, but here there's a long explanation of how these values for the grid is interpolated with the use of stations. For Greenland, there exists no grid like this because the stations are too far apart to make accurate grid cells like this. But yeah, there's also another parameter list for climate data. This is a very long one. I guess climate data is one of those things that are a little bit more up for interpretation. What the exact climate parameters you want. I know that WMO has some opinions about what should be done, but it's not mandatory to do those exact in the institutes. Yep.
Okay, so just in the interest of time and making sure that we're giving everybody looking at lots of different types of data, do we have any questions for Peter before we move on to Anders? No. Okay. Peter, that was really helpful. And
Sure thing.
for the CGI folk, we have a recording of when Peter did a deep dive into the DMI open data offering that we can find for you and share if we haven't already sent that to you. Okay, so I see no hands up or questions. Thank you very much, Morten and Peter. Anders, are you ready?
No, actually not. I can't find this. I think it's because I'm a guest at Teams and they don't have the possibility to share anything. I can't.
Okay.
I tried to send. I will send you my presentation at least, but then I can't demo anything.
Okay. Well, send me the presentation. I can share that for you. Is your demo internal facing?
What?
Can I reach your demo if you told me what the URLs were?
Yeah, I could send you that in the email too. Yeah.
Okay, and we could try and make Jeremy do some proper work and follow your instructions.
Okay.
I'm gonna, in that case, whilst that's happening, I'm gonna go to Rupa if you're here.
Yes, I'm here.
Okay.
Okay, thanks. I try to share my screen. I took a easier route and used more or less ready slides. As slideshow not starting, I assume you can now see the presentation. So EUMETSAT Big Data Services, as we call them. This is overview. We have so-called new data services. They are not so new anymore, but anyway, we have pull data services, EUMET View for getting ready visualized maps and images via WMS or user interface. Then we have a EUMETSAT data store, which is a REST API for accessing data. Also history data, and then we have a data tailor for providing subsetting and other processing capabilities. Then we have push services, EUMETcast providing satellite link, and EUMETcast terrestrial as a new kid in a block, providing near real-time data delivery. And this, notably, this is what EUMETSAT successed for being used for operational services. So only EUMETcast services are providing proper good SLA for critical applications. In addition to that, it's worth noting that EUMETSAT sees this concept of hosted processing or data proximate computing as a part of the data services. So most importantly, we have European Weather Cloud and also Wikio, which are cloud services providing resources close to the data. I'm not going too deep today into those, but just want to note that they are available. And then for some very large and especially old archive data requests, we still have a data center where the users have to order the data, and then it will be totally asynchronously made available for download. So these are manual requests. I'm going to go through these services very quickly and rely that you make me provide me questions if you have any. So data storage is providing a pull data API for especially older historical data, but almost near real time data is there with slight delay compared to the push data mechanisms EUMETcast. It provides an open search API, REST API for downloading data, and also subscription API for getting updates for the new when new data is available. Unfortunately, this REST API is not following any standard, but like EDR or WFS, OTC API records. Then we have also this data tailor, which is provided in addition to the data store REST API. It provides possibilities to subset and aggregate, reformat these quite exotic Earth observation formats to more commonly known formats like NetCDF, and reproject the data and so on. It also it's provided via online service via REST API and user interface, by the way, as data store as well. But it's also provided as a standalone tool for users who need better performance or very large processing requests, providing local installation and CLI, local Python API for the operations. Then worth notable that we are also providing an MDoc CLI and Python library for accessing data store and data tailor. Well, yeah, it's just worth mentioning that we have this as well. Then we have this unit view, which is online map service providing visualizations of the UMChat products. It is providing a user interface containing ready-made visualizations and standard OGC API interfaces for these products, containing WMS, WCS, and WFS. Notably, these services are not providing the whole content of all UMChat data, but just the visualized products. So that's not full all products all data which are available from UMChat. To provide a little bit of little glance on user uptake. So this graph, it's not totally up to date, but it should not have changed dramatically. So in this graph, you can see that in data store there are typically about little over 70 active users, daily users, and products delivered is something like from 1,800 to 2,000, 2,000 products. Sorry, in thousands. So in millions in total. And for UMChat view, we can see that we have it's about 20 million visualization requests per month. Then just a few words about Wikio and European Weather Cloud. So Wikio offers an access to the Copernicus data and including cloud-based hosted processing and tools, meaning that users can really get, for example, Jupyter notebooks or also virtual machines close to the data. It is provided jointly by UMChat, ECMWF, and Merck Olsen and EEA. And it's open basically for publicly open service. Wikio contains the harmonized data access, providing also REST API for accessing Copernicus data, so Sentinel data, and also Copernicus services data like C3S and COMS and so on. Then we have also European Weather Cloud in our service portfolio. I'm not going actually to here, as it's actually a separate topic, and you're probably quite familiar with this. Just one to note two things there. So in contrast to WCAG, European Weather Cloud is available only for closed communities. So essentially net services in Europe of member states of ECMWF and UNCED. And it's the idea in European Weather Cloud is that it is using the same data services what I have presented here, which others are using also. But it provides the resources, computing resources, close to the data, so that they are more efficient, more providing better performance. In addition, in practice, we are providing some data in European Weather Cloud for our users, also in local object storage, so in data buckets for better performance and for such that kind of data which is not yet available in data store. And that's the end of my presentation. What questions do you have?
Thank you very much, Rupa. So any questions from the audience here? Okay, so seeing that, what I will point out is that the thing with our data is that typically data looks quite dull. It's like lots of ones and zeros, or it's lots of JSON, or it's lots of stuff encoded in specialized formats that we use like crib and buffer. And it's not until we visualize it that most of us get some feel for what it looks like. So lots of data being shared by EUMETSAT, but you need some kind of tools to visualize most of it, which is why you also provide pre-rendered products, right, Rupa?
Yes, exactly.
Yeah. Okay. So I see no questions. So in that case, what I'm going to do then is share my screen so that Anders, you can present by proxy.
Sorry for the problem.
It's no problem.
There was a button when Rupa was. Now I could take control. I have take control over the presentation.
Okay, go for it.
Then I have to wait for approval. So
I'm going to allow you to do it. There you go. So I see your cursor on my screen. Goodness me.
We better go with your presentation. I don't know.
Yeah.
Okay. I'm mainly prepared for the API. I actually missed that we should talk about the data, but I'll try to do that on as we go. Our API is also mainly built on based on the Inspire directive requirements that more than 10 years ago now, and we mostly build our APIs between for more than 10 years ago. With the aim of having a lot of cache hit ratio, so that we wanted to have an API which had the repeatable requests. We were a bit concerned at that time about how many requests that we should be able to pull through our internet connection. So that was a main concern at that time. Most of the APIs are sort of you can't query how it's limited how you could do your request. So for an example, you could you request the temperature observation from a surface station for the last hour for one or for all stations within our net. That's a typical question, but the data is built when it's requested. So it's anyhow dynamic, but it's not pre-built. And the actual API is should be simple, and it's more home-cooked REST-based API, quite simple to use, but it's not fulfilling any standard of any kind. And we also decided to have no API keys. We would like it free and open for everyone to use in Sweden and elsewhere. So next slide, please. So this is an overview of our architecture. Yeah, today we have about 1 to 3 million requests per hour. I think it's maybe peaking a bit higher sometimes. And in the front, we have a cache and a proxy and a throttling function to limit the request or the data that's actually been, how fast it's being sent back. That's the part we could, which we could throttle. And this is mainly done with the product called, if you heard about it, called Varnish, which we're using a lot. It's working real nice. Behind that, we have most of which is fronting this is atom feeds, which was one possibility that you could use for Inspire that was allowed back then, and that's real simple things that pointing to metadata, which describe all the data sets that are within our catalog, which are, and there are also metadata for each service, and these are described with the ISO 9, with the ISO 13139 records, which was the requirement within Inspire directive, and the atom feeds is also pointing through these REST API is actually serving with the data, and the data is being served from our APIs are from the beginning. We had CSV but then we add on JSON and XML, and that's mainly home cooked JSON and XML, so it's not standardized as far as it is right now. And we also have an API documentation which you could look in how the API is set up and how it's with the examples and how you could use it. And behind the REST APIs, we have backend services within SMHI. That could be files, databases, and such things that are serving behind the scene. So, any questions around that?
Okay, so Mika.
Yeah, I find it's more like a kind of a discussion or a question. We had to introduce the user login to Helsinki Region Journey Planner because during these times they get so many requests that we had to introduce their kind of a, I call it firewall, that we do not no longer give an open access. So this was really interesting to hear that you have not anymore used kind of the login method. So this was very interesting to see and as a comparison.
Am I right that when we've talked about this previously, what we found as a community, at least in part, is that by looking at the characteristics of the user agent, such as origin IP address, the type of agent, the browser or the client application that's being used, you can develop a reasonable fingerprint for each requestor, and then you can apply API management, such as throttling people's access to control, well, yeah, to stop people giving you denial of service, right? I don't know if Mikko or Anders wants to talk to that a little more.
Yeah, I could say that we had some problems with some users there. We have to then we looked at the API at the IP addresses, since we didn't know which user. We didn't have any keys or email addresses on which user are behind the IP address. In some cases, it's really hard because that could be within the cloud, the application. And then you
true.
But it's some we were trying to find out who are behind an IP address and try to start some dialogue with some of the users, because they had they were not using our APIs in a manner that we wanted. We didn't have any problems serving them, but they really did a lot of peeking on our APIs. We tried to tell them and how often they should do that, and that they should rely on the caching headers and such things. But that was a lot of discussion at the beginning with that. But we never had any problems serving, actually. So really, the way the API was designed. But
it's one of those things, isn't it, Anders, that we have to balance ease of access and convenience to use the API, which means not having API keys, with the insights that we can gather about the people who are using them and the ability to connect with them to provide them more education about the best ways to use the APIs. And I think, Peter, when you did your presentation, you said that DMI had spent a huge amount of time developing great documentation and examples and trying to encourage people to do things that way. And that's an area to be continually invested in. Mikko, did you want to add anything?
Just we have some rate limiting. We are using this F5 called product, which is kind of a firewall and so on. But I'm not sure if we have been having to kind of block anyone. But there is some rate limiting going on. But I'm not sure what exactly.
Yeah, and some other approaches which have been adopted in outside of our community. There's something developed by Microsoft called Planetary Computer, and in this builds on top of their basic Azure infrastructure and the way that they provide access to a lot of data sets, which are actually a lot of them are environmental data sets like we use. They require a user to first of all go to effectively an API endpoint which says, I want to access this data, give me a short duration key, and then they can use that short duration key to access the data itself directly from Azure Blob Storage. You don't have to have be a known user to ask for this short duration key, but sometimes if you do authenticate, you might be given additional privileges, or your key might afford you a higher quality of service, or they might issue you with a key that lasts a week instead of 2 hours or 20 minutes or something like that. So there's a number of different strategies that we can talk about as we go through this discovery phase of trying to identify the sweet spot for API management and making sure that we're providing the right kind of controls that we need. Okay, right. Let me, do we have any more questions for Anders?
You could just show the open data catalog, the metadata catalog, if you like, but we don't have to go into it. If someone like to explore it, they can do that by if you could just.
Okay, so I got this one. The URL you sent me 404 on me.
If you click on the first one there.
This one here?
Let's see. Oh, okay. Sorry. We'll leave it. Come back with a working URL. I think that the one you got perhaps is the only working within SMH. I'm sorry for that.
That's okay. No problem. Okay, so I'm just going to move us over to my colleague Mark Burgoyne, who actually was the original author of the tool which Mikko used earlier. And so what Mark is doing in the Met Office is developing a whole suite of demonstrations of how we can share our data better. And you found all sorts of data sets that we're trying to expose through APIs and give people visualizations and encourage them to say, this is how we can build systems. So Mark, you've kindly agreed to give us a short overview of some of those things.
Hopefully you can see my screen now.
Yes, and we can hear you loud and clear.
Yeah, so I was planning to actually give a run through as to why we're increasingly using the EDR API to expose our data and why we see the value in it. The key from our point of view has been sort of mentioned in several of the other presentations, is the fact that making the data easier to use and easier to access. We've got complex data, and quite often it's got different approaches to actually how it describes what it represents, and we've now had to create catalogs and such. And what I want to do with showing you through this demo at the moment is a lot of this data actually isn't MetOcean data, but it's showing a variety of underlying data types and formats which are used within the MetOcean domain, but also showing the ability to show data which is more than just time and space. It can be just time, and it can be feature or coverage information, but all exposed through the same API. And I'll start here by the fact that you start out with something that allows people to actually discover your API. At this point, it's a start page, and you can then sort of view the collections in that way. But as sort of Mikko was showing earlier on, the collections response is actually, I'll expand this out a bit, JSON in this respect. And it's the key here from an EDR API point of view is the fact that it tries to give people enough information to be able to construct the query without having to be expert in underlying data. What EDR is about is this idea that we, as the owners of the data, expose the information in a way that's easy to understand and easy to comprehend. So that's using standard OGC, the new OGC API approaches to describing things like the spatial extent of the data, the temporal extent of the data. It's having a simple description, but also having the ability, using sort of the links capability within the collections response, to actually point users at that detailed information that's required a lot of the time for presenting our information. It's not needed from query to query, but there will be when you're constructing or you're doing research and you want to and thinking about extracting information. This links capability within the collection response does provide people the ability to publish a link to the detailed documentation needed with anything when you get to data within our domain. As shown earlier, this is the sort of generic client that's been written, and this is another reason why we're keen on using the EDR API, is it makes it possible to build a self-describing interface, query interface, that can talk to the variety of underlying formats that we have and present. The feature, the coverage in the form of sort of satellite and radar information, the feature information is in point observations, or well, lightning data is an interesting one. You could treat it as point information. You could treat it as a sort of coverage information. But the key here is the way that the interface works is this idea of predefined queries which are advertised as capabilities to the data. And this is another strength from our point of view. You only need to implement the query patterns that are actually needed or applicable to the data. So I'll start with something that's as an aside to sort of meteorological data, and this is a sort of underlying coverage data, and you've got a radius query for population density. So I can click on part of the world, ask for the data, and again default to coverage JSON because the client can support it, and it's plotted the data. If I go here again, you can see the coverage JSON as was shown earlier on, demonstrating this data. But the key thing here is from a user point of view, an interface to the data, it's just radius, and the data is described as a collection. We are the ones that then sort of use these standard parameters, and these parameters are shared within the query types. So if I was wanting to do a point query at the same sort of way, change the point. And make a query again, rather than that, it comes back a lot quicker. I've got that. But the query, which is the key thing here, isn't radically different. The EDR query type has changed, and we don't have anything describing the radius or the radius units, but the way everything else is specified remains the same. Now, vector data. In our domain, this would probably be things like warnings, but for this, I'll use sort of roads, as it's a nice static sort of data set. So I can put in and make a query against a vector source and sort of say that I want, let's go radius again and pick that. Anyway, it's gone away and actually extracted vector data information and plotted it on there. The underlying data is vector, but the user, in making a request, it's a radius query again. And all that's really changed from an end user point of view is the name of the collection. All the way they work on the data, the request the data is exactly the same as they would with the population data, which was raster data. One of the things I forgot to mention on the collections response, of course, is the fact that as well as advertising what types of query the collection supports, we also advertise what formats are sort of. So this is another key feature. EDR doesn't specify what formats, so we can return in the usual formats where applicable, or we can transform. But the API has the capability of actually advertising which formats are provided by the supplier for that particular data, making it possible to do these sorts of things. And really can't have a sort of a demo to a MetOcean group without actually MetOcean data. So I'll try some simply ensemble data. So zoom out and do an area query. Pick temperature and pressure. Pick a time range. And again, this is again showing data where we've got these extra dimensions. And in the case of meteorological data, of course, we have time dimensions in there. But with EDR, we've also got an extra dimension, which was the ensemble. So I can pick either individual ensemble members, or I can pick a range of ensemble members. Go away and then plot the data on there.
Our colleagues from CGI, when we talk about ensemble, what we're talking about here is we run our prediction models with 50 or 100 or 10 different variations, and so we call that an ensemble. And then we can use the probability distribution of the answers from the 10 or 50 or 10 or 100 models to determine the likelihood of an event happening. So where Mark is, you picked out ensemble number 0, 5, and something else. Those are particular members of the set, but then we might use that information to anyway, you get the idea.
Just for consistency, of course, I've just made the query against the same data with ensemble members, but the radius query again. So what is different? Of course, we've got an extra dimensions in here. In fact, you've got date time, but we've also got a dimension, which is the ensemble members. And that's described in the collection response, telling you what are available. And finally, I think what I can also do is have a dimension which is our custom axes, which is percentile rather than ensemble member. And I can go radius query on that one as well. But the key I'm trying to get over here is it's to make it easier for the end user, in that they don't have to understand how the underlying data is stored. And it makes it easier for us as implementers. As one, we only have to implement those query parameters that are query types that are applicable to what we want to provide. And two, it separates away from the technology, giving us freedom to use the most appropriate technology for the problem. So in this case, I'll do the percentile query. And it's actually generated a percentile based for the same sort of radius query again. And one thing, final thing, which I should mention as well, is there's always going to be the need to actually serve the original data files, serve up the objects. That's essential to what we do. It's essential for a lot of our end users in the fact that they need to work with those complete sets. So one of the queries is the instances query. You can go away and it'll provide you a list of links to the data. That's the metadata links, but so instance data, and you have links there to the original data files. Oh, sorry, that's an instances request, not a links items request. There you go, that's what I want. So the items request comes back as a list of the available data sets and metadata to describe them. And this is another key thing about the reason why we're keen on the EDR API is the metadata is included in the same API response as the data access point as well. And it doesn't have to be verbose, it just needs to be as detailed, and you can use the link section to actually provide it. One final thing, I think, I keep on saying one final thing. You can also have predefined locations. Another key factor from our query type is the fact that you don't have to rely on the user having to put in their own, define their own areas or their own sort of shapes. You can have these predefined and advertised. And the advantage, this is where it might be useful for if you want to cache data. So you can have an interactive query, but from a user point of view, they are asking for a fixed predefined area. So I could put France. I wonder if I've been hit by this, sort of finally caught up when we're doing it on it. So there it's come back and it's actually got a predefined area location. So that's another option that's within the EDR API. Sorry if that was a bit of a ramble through the capabilities, and this is where we want to go to. So this is what we hope to use, mainly to make this discovery of information, because we provide a consistent way, regardless of the underlying data type, of providing a description whilst also providing the ability to link to more detailed registries where needed, and standardizing the interface as well as the query patterns to make it simpler for people to access the information.
And Mark, the query patterns that we've got, they are, let's see if I can remember them. So we can ask for data at a particular point, ignoring time. We could ask for data at a particular point location at a time. You can ask for a time series of data at a particular location. And from that, you can get one of those wiggly charts that Mikko Visa was showing us earlier. We can ask for data over an area using a radius query, or you saw Mark clicking on a polygon to identify stuff. That would be like a two-dimensional slice of data. We can ask for cubes of data, because obviously we forecast data in 3 dimensions, and we can ask for time series of cubes of data, a hypercube if you like, because the data changes with each time step that we predict in the model. So there are a whole number of, so largely the EDR standard, which has been led by Mark and other people in our community, reflects the kind of ways that we want to interact with our data. And I'm sure if the CGI folks had more questions, Mark, you'd be happy to give them some more details of that offline.
I would. Yeah? I mean, one of the things I didn't show, of course, was the vertical level as well, which is just another dimension on the query. So it sort of adds the ability to specify high ranges as for data. So I'll just finish on that one. It says pressure levels in the base. Ooh. What did I forget to enter? Yeah, enter.
So here, what Mark has done is created some slices through the atmosphere, and 1,000 millibars, 1,850, blah blah blah. Things that make sense to meteorological folk.
Yeah, so that comes as a vertical Z level, and that's a predefined sort of. And again, all the information to populate these, we advertise within the metadata, which again, because it's a JSON file, then the other advantage is the discovery side of things. It's something that is relatively easy to harvest and extract information from because it's described in a consistent way.
The metadata in your service call tells you what Z means, so that you don't have to figure that out previously, which is kind of one of the key things for us, self-describing API endpoints.
Yeah.
Okay. Any questions for Mark?
Mark, well done. Well done. That's very interesting.
Thank you.
Okay. Excellent. So we